going to construct a graph of y equals 1 over x. We start by marking off the x and the y axes. We're going to put 2 out here, and we're going to put -2 here. And I'm going to be kind of careful because I tend to distort things because of the angle I'm looking at which I'm looking at the board. Okay, so there we have that. Now I'm going to put 2 up here, and -2 should go about here. Now I'm going to subdivide the interval from 0 to 2 in half, and I'm going to subdivide that interval now because this is going to be 1. Let's see how I did. Let's see if that, yeah, that's pretty close. Okay, and I've got 1/2 here. Something I see quite often is we'll have 1/2, 1, and 2 equally spaced on a graph. Well, that distorts the graph, so we have to be careful that we have a consistent and reasonably accurate scale when we do this. So we want to do this carefully. Okay, so I'm going to now try to subdivide this interval. See how I did. That's about to say, yeah, it's pretty good. And here. Now I'm going to actually label the 1 above the axis and the -1 and the -1/2 above the axis, because if I label them below the axis, they could interfere with the points I'm going to draw. Okay, so I subdivide here as well. I get the 1 and the 1/2. And actually I'm going to subdivide the interval from 1/2 to 1 and get a mark for 1/4. It's not going to be necessary on this graph, but I did it anyway. It's going to be necessary on the reciprocal square graph. Okay, then I do the same thing here. Did I really get that right? I guess I did. So I'm going to have a mark here for -1, a mark for -1/2, and a mark for -1/4. And I'm not going to label these because the labels will kind of get in the way. We know what those numbers are. Now I'm going to plot the point 1/2, 2. Well, let's actually start, if we have a table, we'll start with -2. Okay, we have -2, -1/2. Well, here's -2, here's -1/2, here's our point. We have -1, -1. So that's going to give us a point about here. And then -1/2, -2. And it's kind of unfortunate that I put the label -2 right where I want to make the point, so I could have anticipated that. I know better. Make a nice clean picture. Okay, so I'm going to have -1/2, -2. That point is going to be down here. And then 1/2, 2 is going to be about here. 1/1 is going to be about here. And 2, 1/2 is going to be about here. Okay, this is my graph of the basic function. And that's it, just these points. Okay, well, now I'm going to draw a curve through these points. It's going to be the graph of the extended reciprocal, basic reciprocal function. Okay, the graph is going to continue on past this point. because the basic reciprocal function, the extended basic reciprocal function, is defined everywhere from -2 to 2. Now we haven't talked much about what happens after we pass this point. It's going to turn out that we get an asymptote with the y-axis, because as you divide 1 by smaller and smaller numbers, it goes into 1, smaller and smaller numbers go into 1 more and more times. Okay, and there's no limit to how small the numbers can be, so there's no limit to how big 1 over x can be. Now, this is big, it's not great, it's big, maybe I'll clarify that. It's big, but it's big in the negative direction, of course, because here we're dividing by a negative number. Okay, over here we're dividing by a positive number, so that the graph will be asymptotic to the positive y-axis. We'll come down to something like this. Now, one error that people make if they try to extend the graph beyond the domain of the basic extended basic reciprocal function, they'll tend to level it off at this point. Well, that's not quite right, as we'll see, because if you divide by larger and larger numbers, the reciprocal gets smaller and smaller and approaches 0. So that this graph doesn't just level off here at this value, it keeps getting lower and lower and keeps approaching the x-axis, and the same thing over here, approaching the negative x-axis as you move to the left. So we don't want to be careless in graphing this thing. Now, the extended basic reciprocal function is represented by this, and we can kind of draw an arrow here to indicate that this continues. We won't draw an arrow here because the extended basic reciprocal function isn't defined past -2 and 2. The complete basic reciprocal function is, and that's an important graph as well. This is all we're going to look at the moment. Okay, so there it is. Now, I've seen graphs that actually, drawn somewhat carelessly, but show the right behavior. I've seen graphs that look like this. Where -1 would be like here, and 1 would be like here, and the graphs appear to level off at a value somewhere around 1 or -1. That's not correct. And another thing is that if you extend the graph out here, well, 1, 1 would be, say, about here, and -1, -1. Okay, well, that's not quite right, but you get the idea. If this is 1, then we've got 2 and 3 and 4 and -1 and -2 and -3 and so forth. This graph goes well beyond the graph of a basic function. It's an attempt to graph the complete function, but the complete function is going to have a graph that approaches the y-axis a little more slowly than this one does. Goes through 1, 1, but then comes down to 1/2, and then 1/3, and then 1/4. Doesn't level off, keeps going closer and closer to the x-axis. So we do have to understand that. Now, the important idea, though, is that we graph the points of the basic function, and then we use those points for the curve. I've seen graphs that don't include points for the basic function, dots or x's or whatever you want. Okay, if it's dots, it might look like this. But those points need to be there. We don't want a graph that doesn't have those points, because if we try to make the graph without those points, our graph isn't going to have the right shape. Of course, it's not going to have a perfect shape anyway, because we're doing these by hand. We're doing them as carefully as we can, but we're not using graph paper. We're just putting down a graph. So, nobody's going to get these things perfect. If you do a good job, though, you'll be able to use the graphs to make good estimates. Now, I'm going to go on and look at a couple other graphs.